First of all, we would like to present the model that we have built, which is the stadium. As we all know, most stadiums today prefer to use roofs to protect spectators from rain and hot weather. However, we are not here to talk about the stadium itself, but rather about the design of the stadium roof that we use for this project. We choose this roof design because it perfectly fits the concept of a parabola, as we learned in Chapter 5.
Now let's look at the structure of parabola. First of all, the stadium has a symmetrical curve shape or a U shape, which is, as we all know, the shape of a parabola. This symmetrical shape helps balancing the weight and the wind on both sides of the structure. Other than that, optimal shading and lighting. The parabolic curve allows the roof to cover a wide area without many support columns. That means it doesn't need a lot of pillars or walls to build. This shape also gives a clear view and better lighting for the audience. Lastly, it's giving more strength to the structure. Again, the symmetrical shape can balance the weight of the loads because it is evenly distributed. That's also the reason why we see many modern stadiums use parabolic roof for the design. Now here is the positions of the directrix, vertex and locus, as well as the scale measurement for the roof.
Material that we use to construct this stadium is box, plastic bottle, glue gun, aluminium foil, and wooden sticks, as well as several other accessories to decorate the model. First, we use recycled plastic bottles as the stadium roof, boxes as the walls and seating areas, and wooden sticks as the stadium pillars. We also wrap the boxes with aluminium foil.
Okay, so now we go to the benefit of using parabola roof, especially stadium roof. Okay, there are three main reasons that are more benefit, but I choose the three main reasons. The first one is the reduced wind current or even a snow current. The second one is good appearance. The third one is a value charm. Okay, the first one is the designs allow rain and snow to slide off easily, reducing the likelihood of water seepage or damage. A significant consideration in climates with heavy precipitation. It means that if we have a storm or if a heavy rain, it will stay strong and not going anywhere. So it given the design advantage and visual appeal. Barrel roof, it means that a roof that use a parabola shape. So a barrel roof have gained popularity, especially in modern minimalist architectural styles. So the second one is a good appearance. In modernist and country architecture, barrel roofs are valued for their streamlined appearance and the spacious interest they create. Besides, their curved vault offers opportunities for unique interior lighting effects. Another reason for their popularity in contemporary design. Also, the curved shapes creates pockets that provides a natural insulating effects, helping to regulate indoor temperatures. So when we enter the stadium, it doesn't feel like hot because it has a natural insulating effect. So the heat will be flow away and a new wind or a cool air will be enter the stadium. And we go on continuously. So the third one is a value charm. Paratime of a timeless, elegant look that adds character to home, suitable for any architecture designs. It is quite good and suitable for anyone who want to use it at their building or even their home.
The question is, the hyperbola has its center at the origin and transverse axis along the x-axis. The vertices are at 50, negative 50, and the foci at square root 34, and negative square root 34. For the first question, write the equation of the hyperbola. So if we look at the statement above, the vertices are at 50 and negative 50, and the foci at square root 34 and negative square root 34. We know that the A is equal to 5 and the C is equal to square root 34. So it already given that equation of hyperbola has 2, which is a square over a square minus y square over b square is equal to 1, and c square is equal to a square plus b square. So if you want to use the first equation, we need to find b first, as we already got a and c. So we just square both a and c and substitute it into the second equation, and we got b square is equal to 9. So we substitute it into the first equation, and the final answer is a square over 25 minus y square over 9 is equal to 1. Second question is equation of the asymptote. As we know, equation of asymptote is y is equal to plus minus b over a s. We know that a and b from the first question, so we just substitute it and we got y is equal to plus minus 3 over 5s. Last question, determine whether the point 7, 3 lies inside, outside or on the hyperbola. So we use the answer that we get from first question, which is x square over 25 minus y square over 9 is equal to 1, and we substitute 7 and 3 into x and y respectively. So we get that 0.96 is equal to 1. So as we know that it less than 0.96 is less than 1, so it lies inside the hyperbola.